Okay, this is my English version demonstration of using WinDbg to peek into the window internal um, structure. So actually, I'm playing the Canon's version, but recording my English soundtrack. I turn on the WinDbg in local kernel debugging. If we want to see the all the processes running in the Windows system, I will use Process Explorer or using the Task Manager to find the active process running in the Windows system. Let me go to the method command. Sorry, should be the kernel mode extension command, starting with the exclamation mark or bang. So the first command I'm going to type is using bang process 00. This first 0 is referring to all active process. The second 0 is referring to the level of information to be displayed. The level referring to 0 to 7. Right now, I only display the minimum information of the eProcess structure. And you will see that the current process is WinDbg with the eProcess structure of A7E0F040. In order for helping me to do the demonstration to you, I extract some information from my WinDbg desktop to my notepad. Now we come to another field called CID, means the client ID in WinDbg. Actually, that is PID, what we call the process ID. What's the meaning of 18B4? I can use an evaluation command that is question mark to show that the PID of 6324, or I can use the dot format command to show the hexadecimal value. By checking with the Process Explorer, you can find out that is 6324. If I want to see more information of the PEB, and if we want to see more details about the particular process of WinDbg by using bang process, I can use the command like the following. We need to avert the eProcess structure address. And the PEB is a pointer to the user mode. Why it is in user mode, it starts with the 0 instead of higher than 7. If we check the 0FF4 as the parent ID, I can type the evaluation FF4 and you'll find 4084. If we want to see more details of the WinDbg eProcess structure, we need to provide the details information. For example, process and change to 2. by providing the exact current process address with the pseudo register. It will show you more information on the current process. Actually, if we want to save time, we should only show the current process by providing the pseudo register in replacing the 0. I mean the first 0. If I provide the first field with the 0, it will try to list out everything. So here, this command on level 2, it will show you more information, including how many threads is running inside this WinDbg program. Will provide the information of thread address. Pay attention, the 9F83 is a running process. So if we are providing the pseudo register with $thread, it will shows only the running process, which is the current process. It will show the current running thread. And the CID of the thread separate by 2 parts. The first part is referring to the process ID. The second part is the thread ID. Can we check the thread ID whether they are confirmed or not? Okay, we're using the same thing to find out the thread ID. Let me copy them outside from WinDbg and put it inside my notepad so that I can use another tool, Process Explorer, to find out whether this information shown inside WinDbg is consistent in the Process Explorer. If we want to do the conversion of running thread, okay, let us check the process ID first, which is consists with the previously displayed in the video. Then if I want to double check the 1E64, it goes to 7784. So let us check the WinDbg's thread, how many thread is running inside my virtual machine. Double check the 6324 is correct. Okay, you will see 7784 inside my WinDbg, which is consistent between the information provided by WinDbg as well as the Process Explorer. And you will see that the PEB and TEB is in user mode environment. Why? Because it starts lower than 7 in Windows 32-bit system. Okay, let us go into the data structure of the EPROCESS structure. Here's the slide that I prepared for you in the class. EPROCESS structure, just like a database, the schema or the table with respective fields. They contain different size, different type. Some important field of this structure I copy into this slide. For example, we have the PCB, PEB. As I said, PCB is an export of some or partial information on a process structure to the user mode environment to allow some other process to making use of this information. The PCB contain a pointer point to the K process. K process is another structure, but one field is important, that is the flat list head, which is similar to the active process name. By enumerating the flat list head, we can find all the flat from original eProcess structure. And the flat list head is pointing to the K-fat. The active process lane pointing to another eProcess structure. Just like there are four, for example, there are four eProcess structure inside my virtual machine, A, B, C, D. That is by using the active process lane of the eProcess A, we can find the eProcess structure of the process B, and B pointing to C, C pointing to D, D pointing backward to A. In actual situation, there are two pointers. One is called front link, another is the back link. By enumerating the front link or the back link, we can find the all active process. And the object table field is a pointer pointing to the handle table. And PEB is pointing to the user mode environment. And this diagram exactly shows the structure, what they are actually perform. And the fact object, which is the K-fact, is pointing to the fact environmental part we call the TEB. And they are all mixed pointing to each other in some way that we can find out in the kernel virtual memory, as well as partial information of the process and flat export to the user mode environment. Using kernel debugging is one of the methods. Now we are going to do the demonstration on the eProcess structure. So DT is the command called display type. Okay, if you want to create a log to capture all the command type and the output generate in your WinDbg section, you can use a method command called log open, and then provide the full path of your log. In my example, I put it in the C root so that I can export to you. And actually, this file already include into my zip file that I share out through the Dropbox link. If you want to check this information, you can download it from the Dropbox links. The first command is try to display type of the eProcess structure. If I just type the DT eProcess structure without address, it will only show you the structure of eProcess structure without any value or linked to any process. And actually, you can type the lowercase without full uppercase. Here we show you the eProcess structure of my Windows virtual machine. Each version of eProcess structure of each Windows version may be different. For example, the first offset is the PCB, which is pointed to the K process. So if we are checking a particular eProcess structure address we can also check the K process. Some of the field is important, more important. So I will pick out some of them. For example, create time adjust D0. So I try to find the image file name for you. Remember this address 17C because we can use the image file name to confirm whether we are on the proper contact and what process we are working on. And one of the students in the class mentioned that we can use the Control F to do the search inside the WinDbg desktop. For example, if I want to find the active process link, it can find through up or downward direction. Okay, remember the offset location, active process link is at the location of B8, which is important so that we can enumerating these pointer so that we can find the next process. Okay, can we check the CID or process ID in the eProcess structure is at the offset of B4. Its name is called unique process ID. For example, if we go to 14C, we can find the PEB at the offset 14C. We can find the PEB of that eProcess structure. If we want to double check whether the name is correct to my current process, we can check the offset 14C to display the image file name to confirm whether we are working on the right eProcess structure. Another part is the 348, which is the exit time. Now we need to provide the actual address of a eProcess structure so that my WinDbg can display the eProcess structure with the value. We can provide the actual address or the current process address in form of pseudo register. Now we double check the values contained inside this WinDbg program. Okay, check the PID. Yeah. Sometimes using Control F is more easier to find the information. And the PCB is pointing to the K process. I'm not check this at this moment, but for example, I want to check the active process link. There will be two location of these active process lane at address of offset B4 from the eProcess address that I provide. For example, if we want to check the PEB, you will find it is in user mode environment because it's starting from 0, which is lower than 7. If we want to find the current process that it shows in the 17C image file name is WinDbg program. Okay, now we can check the create time. Yeah, I keep the D0, which is important. If we want to double check this decimal value, what's the human readable information, we can use the .formats command. Yeah, this is the actual timestamp that this WinDbg program being created. For example, we go to 348, we can check the exit time. Okay, we find the exit time is 0. Why? Because this is an active process. It's still running inside in my Windows kernel's memory. If we want to check parcel information of these EPROCESS structure, we can type the image file name, unique ID. It will show you the only location that we want to check of this EPROCESS structure. For example, we want to check the current process, active process name. It will display you the front name and the back name of this active process name. If you are checking the current EPROCESS structure address plus B8, it will show you the content of the active process name. If you want to expand the embedded structure, you can show the DT of the current process plus the field added a dot. This is the pointer to the other address, but we need only the front name and back name address. Don't forget the offset of active process name is at the address of B8. Okay, if you just want to find the front name and the image file name with the option of the without display the content without the offset, by supplying the I means we don't want the indent. And if we want to enumerating this active process name by front name to find all the current active process, then we need to use the command called list. List actually recursively lists all the front name to another EPROCESS structure so that you can get the same similar result, just like bank process 0.0. What if we try to use backlink to find the similar result? The answer is yes. This left for you as an exercise by checking the location offset of B8. Now we move to another function. If we want to exactly find what is the next process of the current process, aka WinDbg, how we can double check and find the EPROCESS address, we just need the active process name address minus B8. Why minus? Because it's active process name pointing to another EPROCESS structure's active process name. And the offset of active process name under this Windows system is B8. For example, if we want to find the current EPROCESS structure, we can use either the evaluation or we use the DD command to display one value of this EPROCESS structure. So remember, the WinDbg current process eProcess address is at the location A7E0F040. We can explore the other information by using WinDbg by using either DD evaluation, or later on we can find the DA command, which is display ASCII character of a particular address. Right now, we need to remember the current process WinDbg eProcess structure starting address. If we add this plus the offset of the image file name, that is 17C. If we do the evaluation of this address, it shows nothing. But if we change into display ASCII, you will see that I can find the image file name called WinDbg. By adding and minus the offset, we can find the exact information we required. Here, I'm going to do some other way to find the next process by enumerating the active process lane address. First, we need to find the front link or back link. For example, I try to find the current process WinDbg's front link and back link. The front link is 81D24400. That is the front link value inside the eProcess structure of WinDbg. We try to display the content of this address, which is the active process link of the next process. Then we minus B8 because I want to find the original I want to find the eProcess address of the next eProcess structure. So I need to move back to the top at offset 0. Then if I want to find the next process image file name, what I have to do, I need to add this address with 17C. But we measure this by the pointer of active process name of WinDbg to the next following eProcess structure and try to display its name. If it shows some error, we need to double check whether the calculation is correct or not. Well, you will see that the funding changed because the window environment, all these pointer will always be changed because of the new process is created. Now, after we double check the funding of WinDbg, then we can using the WinDbg's funding to find out the next process name. The next process is called trusted install. We can also use the backlink to find the previous process location. The only thing we need to do is change the front link address of WinDbg to the backlink. Now you will see that the WinDbg is sit between the process notepad and trust install. This is the end of the process internal. And then we can also check the PED of each eProcess structure. Each eProcess structure to have a pointer to its own PEB structure in user environment. For example, we use bank PEB. You will find the some basic information such as PEB location of the current process. That is the current process image-based address. Sometimes malware, user mode malware can manipulate this PEB, can create some malicious code redirection by change the image-based address. So this is the current process full path. It is residing in the C programs, window kits, and the debugger. And then you can also be able to find the DLL image location, which is the pointer. All of them are system library or system DLL. And also you can find the environment variable of this particular eProcess structure, WinDbg.exe. Can we see the next eProcess structures PEB? We need to do more things. For example, we need to check the what is the latest active process information. Of course, you will see this highlight in blue character. If you click on this blue character of PEB, WinDbg to help you to direct you without typing the command to go into that PEB to display to you. If we want to check other eProcess structures PEB, we need to change the process contact. How to change a current process? For example, I need to use the command process provide /p to provide with the new process address. Oh, no, not the PEB address. Otherwise, you will have the error just like I'm typing in. Yeah, we need to change it back to the next process, the eProcess address provided with the that process PEB. I suppose be able to find the audio IO's image base as well as the path. So that is the way to show the audio DG's PEB instead of the WinDbg. So if we want to find the WinDbg's PEB, I need to provide the WinDbg's, change the WinDbg's structure, eProcess structure address with that PEB address of the they need to be matched. Otherwise, it won't show you. WinDbg will not show you the appropriate content. So the context should be the WinDbg's eProcess address and the WinDbg's PEB address. Yeah, something wrong. Yeah, it is not the eProcess address. We need to type the PEB address. PEB is at user mode. So you will be able to find the WinDbg's PEB. Can we use active process link method to find this PEB? The answer is yes, but it left for you to be an exercise. Now we are going to the section of the thread internals. How can we see the thread of the current process? Try to use fan process, current process. 2. You can see that my current process WinDbg to have 3 threads with different information that we already copy to my notepad. We need to pay attention. The running process is the current thread. The others is waiting. The actual running thread is the thread ID of 1E68. Try to type question mark. That is the address of the 9F whatever. And also the TEB, just like the PEB is in the user mode environment. Yeah, the TID, thread ID is 1E68. Then we'll move to our slide. So thread do have its internal structure, including the TCB, just like the PCB, and also the create time and exit time. The TCB is the location of pointing to K thread. K thread do have different structure, including the stack, base, kernel stack. Yeah, remember that I mentioned in class, kernels do have a stack. And also that is priority from, I think from 0 to 15, totally 16 level. And actually from EPROCESS can point to the TEB that is in user mode environment. Okay, we go back to our demonstration in virtual machine. Okay, let's check the EPROCESS structure. DT, discrete type E flat. Now we provide the pseudo register thread, current thread. That means 9F839040. So it comes with the current threads with the thread value of the WinDbg process. We need to consider TEB. The TEB exact address is the same of the current thread. Then if we add 358, we can have the current time of this thread. If we add 360, we can have the exit time of this thread. The CID, which is the thread ID, is at the location of 384. And then we go to free BC, I can find the flat head, which is similar to the active process link. If we enumerating the flat list head doubly linked entry by the front end and back end, we by the front link and back link, we can find the next flat. For example, if we want to check the link, we can find the time here. If we want to find the K-fact, we can provide the same current flat address because they are on the same location. Here is another structure called the K-fact structure. We can find more information such as a stack base at address 028. This is a kernel area. And also we can find the kernel stack. Is it a running? You find 1, that means it's running. For the waiting, if you find another flat address, it will show 0. And also there is a field called stack context that I have mentioned in the class, which is at the offset of 83C. Here you find the value right here. And then we move to 8, pointing to the user mode environment, the TEB of this flat. And then we go to 150, you find the process. That process is the actual EPROCESS structures address. You find the same information of the current process. From right now, you may be able to identify that all these structure mentioned in the Windows kernel environment, they are pointing to each other, which is some kind of mesh or pointer to pointer. You can find they are perfectly linked together with these pointers. EPROCESS structure, K-process structure, E-flat or K-flat, TEB, PEB, they are interconnected with different pointer, perfectly linked together. If by measuring these flat head by adding the offset of 1D4, and then we can follow this front link or back link in order to find the next flat. For example, if we want to display the current K-fact, if we provide because K-flat is also coming from the EPROCESS structure, PEB. So if we type this information, we can find the PCB. Oh, that is not correct. We need to type back the $. You find the offset is K-process. We can find the K-process from E-process. If we want to see the K-process details, we can provide the same current process address. And this K-process is pointed also by the thread. If we are enumerating the process lead entry with the offset X0, or using the thread list head at the offset 2C, we can list all the lists by their K process structure. We provide the thread list head. We can see all the threads running inside this EPROCESS structure. Each thread's information will be displayed by this list command. For example, right now we want to display the current thread information. We can also find the similar information. Then we are starting from the current thread, go to K thread, we can find the same information. If we want to see only K threads thread list entry and TCB and the process information, it will show you by adding this information. If we don't want the indent, if we don't want to know the offset, it will show you the information by typing the command like this way. So can we find the next thread information by the current thread? I left it for you to do the exercise at home. I hope my demonstration can help you to understand the Windows kernel, especially in the processes and thread more details. And thank you for watching this video.